Hello, everyone. Thanks for joining us on another episode of Bob Friday Talks. Today, I am joined by Oscar winner James O'Brien, Professor of Computer Science at UC Berkeley. James, maybe we can start with giving the audience a little bit of your journey. How did you go from professor to Oscar winner? Where did the journey start?
Well, my journey in visual effects and I guess visual computing in general started when I was a grad student at Georgia Tech. I became very interested in the idea of using computer simulations to create visual imagery. And so that's what I focused my PhD work on when I was at Georgia Tech. After I graduated, I came to the professor position here at UC Berkeley and still focus a lot on visual effects, but also sort of branched out to using simulation optimization for a whole wide variety of problems. Again, mostly related to imagery, so what I would call visual computing.
Now, you've been a professor at Berkeley since 2000?
Yep. Yeah, since 2000, about 25 years.
Okay. And so we're here today to talk about AI. So I thought maybe we could start the discussion a little bit about how you see AI affecting our education, university. There's a lot of talk about ChatGPT.
Yeah.
What are you seeing inside the Berkeley right now?
Well, I've had some firsthand experience with this, right? In a couple of ways. This semester I'm teaching a graduate course, but last semester I was teaching a large undergraduate course, and I was going to give them a take-home final, and I wanted to run the questions through GPT-4 just to see what would happen, and it got them all right. And so I said, okay, well, let's make the questions a little trickier, a little harder, and it still got them right. A little bit trickier, harder, and then finally it was getting them wrong. But before I could give the test to my students, I want to give it sort of a dry run, a test out. So I asked my grad student TAs, would you to take the test? And by the time I made it hard enough that GPT-4 didn't get it right, the grad students didn't get it right either, which is it's sort of a little concerning. Like what is it that we're going to be teaching in our classes? And the other experience I had with AI in this class was that we had, at one point, one of my TAs came to me and said, hey, listen, I've got some cheaters. And we've got several students who all turned in almost identical code. And so I sat down, I talked with these students individually, one by one, and they all had the same story. They didn't think they had done anything wrong. They were told, we were told to use Visual Studio to work on our assignment. Visual Studio includes Copilot. We use Copilot. It wrote some code for us, and what was wrong with that?
Yeah, for me, Copilot has become, for summarizing meetings now, it has totally changed my way I work now, right? I don't have to take notes anymore. I just have Copilot help summarize it. But when you look inside of our educational system, do you really see that this AI is a positive, negative? For me, I kind of look at it as like calculators. When side rules calculators, everyone's like try to ban calculators. How do we adapt to this new AI tool that's affecting all of our lives?
Well, I mean, this is why I didn't penalize the students in any way, right? If those students were out working in the world and they had a job to do, then it would be totally reasonable for them to use Copilot, just like it would be totally reasonable to use a calculator. It doesn't make sense to tell them not to use it. It does create the problem because we do want to teach basics still. We still want to teach the fundamentals, and now it's kind of a little bit of a problem because if the students can use the AI tools to do the fundamental work, to do these basics, how do you test them on this? How do you teach the students not to not use the calculator, but to understand what the calculator is doing so that when they use it, they know how to use it in the right way?
Well, I'm with you because, when I was growing up, it's like you still have to learn your multiplication tables.
Exactly.
You have calculators. So what do you think the answer is now? We're in this new environment. People have to learn the basics somehow. When I look at the educational system, and I think when we discussed earlier, 30, 40 years ago, I had to buy books. I was trying to learn to build wireless networking, radios and everything. Nowadays, I don't buy books to learn stuff. I go to the internet in the cloud right now. If I want to learn some new AI topic, I learn it on YouTube.
Right. Even before we had the AI tools to write software, it was also the case that you could find a lot of if you had a problem to solve, you could look on GitHub and find some example code that somebody else had written. And I guess there are copyright issues when you're looking at somebody else's code, but generally speaking, if you have a job to do, you want to use the best tools to do the job. Whether it's finding open source code or using an AI tool to generate new code, you want to use the best tools to do the best job you can. But that does make challenging to try to teach the students, right? Because we need to now adjust how we teach them. Just like we don't have them memorize lots of stuff anymore because it's not necessary, they can look it up. How do we evaluate them? How do we teach them in a useful way? And when we talk about grades, how do we give them grades that make sense, right? if everybody's able to do the assignment and do it perfectly because they have the tools available to do it perfectly, do I give them all A's? Do I find a way to somehow differentiate them and not give them all A's? What do I do? It's a challenging question.
Yeah, I mean, so now Juniper and Mist, right? We're in the networking business. So I'm curious now, like when you're giving your tests in universities now, do you let the students use the network and access these tools while they're taking the test, or you have kind of a no network policy going on?
Well, if they're taking a test inside the classroom, then that's easy. They can put their phones away, and we notice if you have your phone on the desk. And so that's a little bit easier of a context. It's really the take-home stuff, a take-home final, a homework assignment, a project that they're doing on their own. I mean, luckily, the class I'm teaching, they tend to be like I teach upper division classes and graduate classes. And in those, they have project work. And for the projects, we say, whatever resources are available, use those resources, right? It's just like if you hired someone to do a job, use the resources available to you. For the lower division classes where they're learning the basics, where they're learning the fundamentals, I think that the question is a lot more challenging because you do still want to learn those fundamentals, and the university requires us to give students grades, so we want to test them on the fundamentals. We want them to learn the fundamentals, but we also don't want to create a situation where the honest students do the work and then get a grade that might not be an A, and the dishonest students use some other system, use a generative AI to do the work, and they all get A's, right? We don't want a system that's unfair. I don't think there's a clear answer yet.
Well, maybe the other topic I wanted to try to cover a little bit in this session today is really around your career in film, because I know you were the inventor or one of the co-inventors of digital molecular matter algorithm. Did I get that right?
Yeah. Yep.
Okay. And for those who don't know, have you ever seen the first Avatar movie? James Technology was in that movie.
It was. Some of the X-Men movies as well. It's actually been used in over 200 films. And what the software did is it's kind of what I described earlier. If you want to have a scene where something is, a building is being blown up or a spaceship's crashing into something, instead of trying to build a little model and film it and try and make it look right, you set up a simulation. You want a building to be sat on by Godzilla and collapse. Well, you take a model of the building, you build the building virtually, and you set up a big finite element simulation that's going to compute, as the monster pushes on it or whatever's happening, what are the forces in the building, how's the concrete going to crack, how will the windows shatter, and it actually computes all this and generates the raw data that then goes into what we call a renderer that creates the images. And those are the effects that go into in the film. That's what you see. You're not looking at something real. You're looking at something that was completely virtual.
So I have to ask you, of all the scenes, all these movie scenes, I think you're in like technologies in 90 or more feature films. What scene stands out? Do you remember the most? You go, hey, that was me. That was my technology making that happen.
So actually, the first movie that really used a lot of our software was the movie Sucker Punch. And I guess it didn't do super well in the box office, but it has some beautiful special effects. Mm-hmm. And to me, that's the first place that our software was really used in a very major way. It's I forget, there are lots and lots of scenes that used it in the movie very heavily. And so for me, that's a very special one. There's also, in addition to the movie industry, we've also used the software for video games. So Star Wars: The Force Unleashed was the first game that came out that made extensive use of our destruction modeling software.
Now, I know you started this adventure back in 2000, and I think when we talked about it, you started with finite element, the DMM algorithms. Maybe you give the audience a little bit of the journey from 2000 to where we are today. When we look what's going on in the film industry, and we have actors and writers going on strike, being worried about AI. When did this AI really start to become a thing inside the film industry?
So AI, machine learning, deep learning, we have different terms for these things. This has been, as the techniques, back in like the 90s, for example, the the capabilities of AI systems were very limited, and so they weren't used for a lot, at least not in the movie industry. But by the time you got to about like 2017 or so, the systems started to be much more powerful, much more useful, and so you'd see them being used as a component. Right, so if I want to animate a character, I hire like in the movie How to Train Your Dragon or something like that. I hire an animator who animates Toothless by hand. But now maybe I can create a tool, an AI tool or machine learning tool that makes it a little bit easier for them to do it. So rather than very painstakingly moving something and then waiting for an update, it will be more smooth because the AI system is able to more quickly compute the answer. But you still have a human animator doing the work. And what we're seeing now, of course, is these generative AI systems that can actually create the special effects themselves. It's a sort of a phase transition. It's very different than using the AI system in a traditional pipeline. You're now getting sort of a new pipeline that's built around the AI systems.
And when did this Gen AI, I mean, when did that happen? I mean, it sounds like, somewhere from 2000, somewhere, it sounds like in 2017, we started getting machine learning help speed up these action scenes. When did these actors and writers really have something to worry about?
Well, I think in the last couple, literally last two years, basically, it's become very clear that we now have generative AI systems that are capable of producing images that are almost indistinguishable from reality. They still make mistakes sometimes and give you extra fingers and stuff like that, but the systems are getting better, and these problems are becoming fewer and fewer. We also have now systems that are able to do video, so animated sequences, not just still images. And there's a good and bad side to this, right? The good side is it's very democratizing, right? If you and I wanted to we had some great idea and we wanted to make a film about the story we wanted to tell, well, today or maybe yesterday we would have needed a big team of people to do it. Like even right now in the studio where there's a team of people running cameras and so on, it's kind of a big deal. But if you have an AI system where you can simply describe the scene you want and it'll generate the imagery for you, then now it becomes possible for individuals to now produce high quality video. The downside is that there are a lot of people whose profession is to make that high quality video or make some aspect, some piece of it, and it's concerning. Those jobs might go away.
Well, so I'm in the networking space here. What I always tell people, and I get the same question, is like, Bob, what's different about AI versus what we were doing 30 years ago? And I usually tell them that we're kind of moving. AI is really this next step in the evolution of automation, right? The difference here is, in the past we were building very deterministic, repeatable things. Robots that built your car, a script that did the same thing. This AI automation is really starting to do things on par with humans, some sort of cognitive reasoning skill, right? And that's kind of what we're seeing with ChatGPT. So in that sense, we're starting to build automation that is replacing humans, which kind of leads into our next kind of question. In this next thing, most technologies typically they eliminate jobs, but they typically create more jobs than they eliminated. So when you look at what's happening with AI, automation, movies, even maybe in education, professors, any concern that you're going to get replaced? Professors are going to get replaced by AI assistants?
Well, I think everybody should. As these machines, as you said, they're getting basic, where essentially the machines are able to sort of emulate cognitive skills, right? They can make decisions. They can sort of look at general situations and make general purpose decisions. And I think that what that means is that no one's job, whether it's my job as a professor, an artist's job creating something, any profession you have can potentially and probably will get to the point where our automated systems, our machines are able to perform that task. And I think that this is a little different than what we've seen in the past. In the past, we would see technologies that made people more efficient. So I have a factory, it makes a certain number of cars, and now I get the assembly line, and now it can make the same number of people can make more cars. But if I want to make twice as many cars, I still need to hire twice as many people, right? Or then I have robotic arms that might help build the cars, but I still need people to oversee that. So now the same factory can make 100 times as many cars, but I still need people running the factory. At some point, we'll get to the point where the number of people you need in the factory is zero. And that's now very different, because if I want to scale up today, I need to hire more people. If I want to expand, I need to hire more people. There are more jobs that get created. But if I need zero people to run the factory and I want to now scale up my factory to make twice as many cars, well, I still need zero people. And so that's a big difference. Zero is different than every other number.
Yeah. So I kind of get, hey, we're starting to automate human tasks. I hear we're going to have robots walking around the hospital cleaning things here shortly. When you look at the Berkeley and what's happening on the university there, the campus there, any examples where you start to see AI starting to automate things at the school or the campus itself?
Oh, I mean, I'm not exactly sure what the administration's doing in terms of deploying AI systems. I suspect there may be, universities tend to be a little slow in terms of how they move. So I suspect you see, out in the industry world, you'll probably see more automation being done with AI systems. I do think that there's a question about teaching that's very relevant. So I already mentioned how the students might use AI, and we have to evolve how we teach them to now encompass this, just like we changed how we taught when calculators became a thing. But we also have the question about actual instruction, right? If I'm teaching a grad class to a small group of students, that's great. I sit down with the students, we basically talk one-on-one. It's a conversation. But if I'm teaching a large undergraduate class and I've got 300 people in my class and I'm lecturing to them, I think it's a real question. Maybe they'd be better off having a one-on-one tutor, an AI tutor, teaching them the subject material. I mean, I'm an expert in that material, and I think I do a good job teaching the class, at least I hope so. But I have to ask the question, maybe the student would be better off if they had an AI tutor.
So we look at the university right now, and I'm trying to think, with the AI coming, if you have a student, someone's coming into, headed to college, any guidance or recommendations, you look forward in the future where AI is going to be impacting all the industries. It's going to be impacting how we do our work, to our point we talked about before, it may be, being a plumber may be the safest job in the future.
It is true that any job where you basically are putting your hands on a keyboard, that's a little bit easier to automate using AI because if you're putting your hands on the keyboard, you're working digitally, and that's the domain of these computer systems. Now, if we talk about a job such as you said a plumber or electrician, somebody who has to use their hands to actually run some wires in a building. Even if we had an AI system that's capable of understanding and deciding what should be done, there's still the matter of dexterity. Being able to actually push the wires and run them, or whatever it is that needs to be done. You need a dexterous human to do it right now, and our robotic systems aren't there. So I do think that as we look at jobs getting replaced by automated AI systems, I think the jobs that will take longer to be replaced, eventually they will because the robots will get there, but the jobs that will take longer to be replaced are the ones that actually require physically manipulating something.
Okay, maybe we wrap up. I'm Jupiter Modest. I'm in networking. Wireless mobility. Any thoughts on where you see mobility impacting the future of either film, professorships, campuses?
Well, one of the big limitations on AI systems right now is that they consume a monstrous amount of electricity, both for training, but that can happen in your server farms. But then there's also the actual real-time use of it when you actually use the AI to answer a question or draw a picture or whatever. And right now they use just tremendous amounts of electricity. And the idea that you can now, and more than capable, practical carry around in your pocket, right? It'll drain your phone battery like that. And so, people are looking at ways to make the electrical demand smaller, but one of the big important ways that you can address this problem is you move the computation into the cloud, and now I have my device that I'm carrying with me, whether it's an Apple headset or a phone or whatever, and the computation that I'm using personally as I move around in the world is being relayed from the cloud.
Okay, so this is like moving computation to the edge. This is like AI at the edge.
Yeah.
Do I want to do this on my phone or back in the edge? The other thing I'd be curious about is, in your classes now or in the film industry, are you moving to GPUs? Are your classes actually using these big GPU AI clusters?
Well, yes, they are. We've been using them for a while because we also did computer graphics on the GPUs. Once upon a time, we actually used the GPU graphics processing unit to do graphics once. But now more and more it's being used to do AI type stuff. If you don't mind plugging, I'm involved with a startup called Juice Technologies, and their whole product is a way of virtualizing GPU, so that you've got a machine here, your GPU's off in the cloud, and you can access that GPU as if it was on your own local device, and that makes it mainly makes your programming development a lot easier. So yeah, GPUs are used ubiquitously all over the place.
Yeah, Juniper's big on networking for AI. And that seems to be one of the big transitions happening, moving from this x86 data center to mostly a GPU data center. And they almost call it front of the house. We have x86 in the front of the house and we have GPUs in the back of the house. And it seems like, NVIDIA is now the third most valuable company in the world. You started it with the graphics, right? All that GPU stuff started with digital graphics.
Yeah.
And Gen AI now seems to just be driving an exponential growth.
Well, when there's a gold rush, you make your money selling shovels.
James, thank you for joining us,
It's been my pleasure.
and look forward to seeing you on the next episode of Bob Friday Talks.